Hello everyone, welcome back. This is Aishwarya. Today we are going to discuss the topic the probability. What is the meaning of probability first? Where the probability is used, where the word probability is used, it is used to convey that something is very likely to happen. That is, the extent to which an event is likely to occur. That means there is a chance of getting rain, probably it may rain today. That means the chance, the sentence when we are using to say that there is a chance of getting the favorable condition. That is nothing but the probability. This probability is explained making use of the terms experiment, sample space, and event. Let us go in deep about each and every individual topic. Let us see. Probability. The word probability is commonly used in our day-to-day conversation, and we generally use this word even without going in details of actual meaning. For example, as I already said, probably it may rain. The word probability is that is nothing but the chance of getting. Yes, probably it may rain. That means the chance of getting rain. It may rain today. Yes, Indian cricket team has got good chance of winning World Cup. In the above statements, the terms possible and probable, they convey the same sense that the event is not certain to take place. You're not predicting the exact outcome. Yes? There is uncertainty about the occurrence of the event. This is the concept of probability. Let us see the theoretical approach to probability. In theoretical approach, we try to predict what will happen without actually performing the experiment. In theory of probability, we deal with events which are outcome of an experiment. For example, let us consider a fair coin. The possible outcomes will be head or tail. Before actually performing the experiment, you are predicting the outcome of an experiment. Yes. The experiment means an operation which can produce some well-defined outcomes. And this experiment is classified into two types, that is a deterministic experiment and random or probabilistic experiment. Let us see the difference between these two experiments. Deterministic experiments are those experiments which, when repeated under identical conditions, they produce the same result or outcome. For example, when experiments in science are repeated under identical conditions, we almost obtain the same result. For example, in physics we have Ohm's law. The output of that experiment will be same, but there are some slight changes under identical conditions, but that is a deterministic experiment. Let us consider another example. Let's take some water into the bowl. When we expose it to the sunlight, what happens? It gets evaporated. That is a deterministic experiment. Next, the random or probabilistic experiment. These experiments, which when repeated under identical conditions, don't produce the same output every time. But the outcome in a trail is one of the several possible outcomes. That means, consider a bag. Consider a bag which consists of 5 balls. Say these balls are of different colors. These balls are of different colors. When we pick a ball from the bag, we cannot determine whether the ball which we are going to pick up will be of specific color. That means for every time when we pick a ball that may be of different color, that we are not certain about saying, that is uncertain. Those type of experiments are called random or probabilistic experiment. Also, when we toss a coin, we are not sure if a head or tail will be obtained. So, it is a random experiment. Yes. Next, elementary event. An outcome of a random experiment is called elementary event. For example, consider the random experiment of tossing a coin. The possible outcomes of an experiment are head or tail. Generally, we define the event with capital E. Let us consider E1 is an event getting head on the upper face of a coin, and E2 is an event getting tail on the upper face of the coin. These E1 and E2 are elementary events associated with experiment of tossing a coin. Compound event. An event associated to a random experiment is a compound event if it is obtained by combining two or more elementary events associated to random experiment. In a single throw of dice, we have 1, 2, 3, 4, 5, 6. This is called sample space. That is, the possible outcomes, the set of all possible outcomes of an experiment is called sample space. The event getting an even number is a compound event. That is, from this sample space, the subset of getting an even number is 2, 4, 6. This is a subset, right? The subset of sample space. 2, 4, 6. This is an event of getting even numbers. As it is obtained by combining the three elementary events 2, 4 and 6, this event is the compound event. Probability of an event. If there are n elementary events associated with a random experiment and m of them are favorable to an event A, then the probability of happening or occurrence of event A is denoted by P of A. That is nothing but we always say the probability in the probability is always defined by number of favorable outcomes to A by total number of outcomes. Let us simply take an example. Just now we discussed about dice. For the sample space of dice 1, 2, 3, 4, 5 and 6. This is the sample space. Yes? This is the total number of outcomes. Sample space is nothing but total number of all favorable outcomes. That is the total number of outcomes, favorable outcomes, the sample space. Here the sample space is 6. As it consists of 6 elements, the sample space here is 6. And let us consider an event which consists of an even number. That means when we roll a dice, the event of getting an even number is 2, 4, 6. That is 3. Number of elements are 3. Let us say for this the total number of outcomes are 6 and getting the chance of getting an even number is 3. That is 1 by 2. The probability of getting an even number on a die is 1 by 2. That says in this formula, which is nothing but the number of favorable outcomes to A by total number of outcomes. Here we are saying the total number of outcomes for the dice is 6 and number of favorable outcomes of getting an even number, that is an event which consisting of even number are 2, 4 and 6 and the number of elements in this are 3. Therefore 3 by 6, which is nothing but 1 by 2. Yes? That is that the same thing we are saying here. There are n elementary events associated with the random experiments and m of them are favorable. So, which is nothing but m by n. Now, let us see the range of probability. The range of probability. What is the range here? See, 0 less than or equals to m less than or equals to n. Divided by n. Divided by n. So, m by n and n by n. Here, m by n and n by n. 0 less than or equals to, here m by n is nothing but the probability of A, P of A less than or equals to 1. That means the range of probability always lies between 0 and 1. For example, here let us see the probability is 1 by 2. That is nothing but it is not 0 and it is not 1. The range is lying in between 0 and 1. The probability always either equals to 1 or less than or equals to 1 but greater than 0. When we solve a problem, if you get a negative number or the number greater than 1, definitely you have to fix that the one which you solved was wrong. Sure event or certain event. If P of A is equals to 1, then we say that A is sure event or certain event. Suppose consider a bag which consists of all black color balls. All black color balls. Then probability of getting a black ball is always 1. That is a sure event. Whenever you take one ball out of this bag, the color of the ball is always black only because we are considering all black balls in the bag. That is a sure event. Yes? Clear? Next is impossible event. If P of A is equals to 0, then we say that A is impossible event. For example, an experiment of throwing a dice, let E be an event of getting 7 on a die. Is it possible to get 7 on a die? No, because on the die we have only the numbers from 1, 2, 3, 4, 5 and 6. Is there any chance of getting 7 on a die? No, that is impossible event. Yes, therefore P of E is equals to 0. As die has only 6 outcomes and an outcome of 7 is never possible. Therefore the probability of getting 7 on a die is 0. Here P of A is occurrence. Okay, and P of A dash is non-occurrence. That means the chance of getting is P of A, the chance of not getting is P of A bar. That is the negative event is denoted with P of A bar and the positive event is denoted with P of A. That is A is any event, A dash is any negation of event A. That is the sum of occurrence and non-occurrence is always equals to 1. For coin, let us consider for a coin. When we toss a coin, the chances of getting head is 1 out of 2. The chances of getting tail is 1 out of 2. That is half of possibility, right? The probability of getting the head is P of A. Probability of not getting head is P of A, which is equals to 1. Okay. The sum of occurrence and non-occurrence is equals to 1. This is very important. You need to remember this always. Sum of all the possibilities is always equals to 1. All possibilities is equals to 1. That is, let E1, E2, so on, En will be n events. Then the sum of all these events, P of E1, P of E2, P of E3, P of E4, so on up to P of En is always equals to 1. As we know that the range of probability always lies between 0 and 1. Probability of an event can never be negative. We already discussed. Okay, thank you. Let us discuss about the points in detail in the next lesson. Thank you.